In this chapter, we'll be dealing with simulation. Simulation helps us model uncertainty. It shows us how uncertainty in the input parameters influences the results of our analysis. If you will, it can be seen as a sophisticated form of sensitivity analysis. We will start our discussion with a very simple example. This is a problem where we are given the unit price, unit cost, and the fixed cost for an item. Given the unit price, we can calculate the quantity sold based on a very simple demand model. Once we have all those pieces of information, then we can calculate the total revenue and total cost, then come up with total profit. What separates this problem from what we have seen so far is that unit price, unit cost, fixed costs are not certain, and also there's a portion of quantity sold that is likely to be uncertain as well. And in the problem description, we are told how to model each of these uncertain parameters. When you're dealing with a simulation problem, the first thing you need to do is create a model for the base case with no simulation in it. That way you can debug the model better without the additional sophistication and complexity of the simulation parameters. So here we do exactly that. The unit price is given to us with a distribution. I will choose the most likely value as my base case. The unit cost is given to me again with a minimum and a maximum. I will choose the middle between the minimum and the maximum. The fixed cost is given with a mean and a standard deviation. I'm using the mean here as my base case, which helps me calculate the quantity sold based on the parameters of the model. I'm using the int function here so that I can get an integer number of units sold. Once I know the quantity sold, I can calculate the total revenue by looking at the price versus quantity sold, and the total cost is simply the summation of fixed cost plus the total variable cost. And eventually I calculate the profit. Now, I have chosen certain values for the base case. In general, it's best to choose the most common and most likely values for the base case, but it will completely depends on what type of a situation you're dealing with to decide what those values are going to be. In the base case, as you can see, I'm making a profit of around $13,000. But I know that the parameter values are going to be uncertain. In a realistic setting, the next question you need to ask yourself is how to model these uncertainties. In this particular example, we are given some very common ways of modeling these uncertainties. That's now what we're going to add to the model. For that, I'm going to add some more layers to this base case model, and I'm going to call that my simulation template. In the simulation template, I have the model settings for unit price, unit cost, and so on. Now let's try to model each of these parameters one by one using Solver platform. The first thing I'll model is unit price. I'm given that unit price is a triangular distribution with a minimum, a most likely value, and a maximum value. In order to tell Solver platform how this distribution will be modeled, I go to C3 where I would like to add my parameter. I go to distributions, I go to common, and here I choose triangular. And in triangular distribution, you need to give three parameters: the lower point, the higher point, and the most likely point. The minimum is D3. The most likely value is E3. And the maximum is F3. Other than that, I don't need to change anything in this dialog box. And as you can see, once I enter those three parameters, I see the shape of my distribution. I hit save, As you can see, I now have a number generated within these limits. And if you look at the formula here, it says PSI triangular D3 E3 F3. PSI triangular is a solver platform function. Once you add the solver platform add-in, you will be able to get to these PSI parameters. And the triangular distribution always have 3 parameters. And notice that once you add an uncertain simulation parameter to a spreadsheet, each time you type something in a cell and push enter, the value in the uncertain cell is going to be changed because Excel is generating new numbers. The other thing to note is if you hover over a cell that has uncertainty in it, Solver platform will show you what type of uncertainty is modeled in this particular cell. Now let's do unit cost. Unit cost is set to be uniform with a minimum of $12 and a maximum of $15. Again, I go to distributions, I go to common, I choose uniform. Again, the lower value for the lower limit for the distribution is 12, D is 6, and the upper value is 15. Save. Again, as you can see, I have a number generated between 12 and 15. The next one that I'm going to model is the fixed cost, which should be a normal distribution with a mean of 30,000 and a standard deviation of 5,000. I can model this again using the distributions common and normal option, or I can actually type this as well. So I can just PSI, and then when I put N, I see PSI normal. I double click on it, and then I click on the function argument button. It says what is the mean? The mean is D9 and the standard deviation is E9. And as you can see, it already quickly gives me a possible value here. I hit OK. Again, I get another value for the fixed cost. Now that I have modeled all these three, the only thing that remains is the random portion of the demand model. And again, in the problem, I'm told that the random term is given by a normal distribution with a mean of 0 and a standard deviation of 10. Let's do this by the distributions option. Distribution, commonly used ones, go to normal. And again, in normal, I'd like to enter the mean, which is going to be H12, and the standard deviation, which is going to be I12. I save, and I get my random part as well. Now I have all my parameters defined as uncertain, and I have described what type of uncertainty is associated with each parameter. Now, if you keep pushing F9 in your computers, if you're using a PC, you will see that Solver platform will generate different numbers for these parameters over and over, and then you will see different values for the profit. What you would like to see is what the distribution of profit is going to be, given that we have different characteristics for the uncertainties of different parameters. The next thing we're going to do is tell Solver platform that each time it generates a different value for this parameter set, we'd like to observe what happens to the distribution of the profit. For that, I go to C17 and I'd like to tell Solver platform that this is the result cell that I'd like to be observed. In order to do that, as I'm in C17, I go to results in this drop-down menu, I go to output, and I say in cell output. Now what happened here is the function here has been updated. In addition to the portion of the function that calculates revenue minus cost, I have a plus PSI output function which tells Solver platform that this is one of my outputs, and each time a simulation trial is completed, I'd like to see the result of this collected. Now that we have set up our parameters and we have told Solver platform what value we'd like to analyze as a part of our sophisticated sensitivity analysis, the next thing is to complete a simulation run. To do this, I go ahead and click on the Simulate drop-down menu and choose Run Once, and then I will get this summary. So let's see what this means. This tells me that Solver generated many different values for all my uncertain parameters and kept observing what happens to the profit function, and then it created a histogram to that. So now let's make this a little bit bigger and examine what's going on here. So this is my profit in thousands. As you can see, most of the time my profit is more than 0, so I have a positive profit most of the time. And if you want to know more statistics about this, you can look at the values here. The mean here tells you your average profitability was around 10,000, almost 11,000. You also have the standard deviation, etc. Another interesting one is the maximum. In the best case scenario, your profit was around $33,000, and in the worst case scenario, your profit was around negative 9,000. The problem asks you 3 questions. Part A is the expected profit, which is the mean. Part C is the maximum loss, which is this value here. Part B asks you what is the probability of loss. So you'd like to see what percentage of this histogram is on the negative portion. In order to do that, you can go ahead and lower cutoff option here and put 0 here. And just get out of that. When you get a lower cutoff, it divides your histogram into 2 portions, values less than 0 and values more than 0. And it shows you that given this setup, there is a 93% chance that you'll have profit, and there is around a 7% or 6.6% chance that you will see a loss. Now, these values are not set in stone. If you do your own analysis, you may see values that are close to this, smaller or larger, but you will rarely get the exact same numbers because Excel is generating random values for each parameter. In fact, keep this 10,700 value in mind, push cancel, and then go ahead and optimize again, run once. Now as you can see, it's still 10,700, but it's slightly less. And let's look at the probability of loss again. So this time it's, instead of being 6.6%, it's 5.8%. So again, more or less in the same ballpark, but not exactly the same. So that concludes our first example that shows how to run simulation models in Excel using Solver platform.